In this video, we are going to talk about how to recognize the graphs of one-to-one functions just from the graph alone. Again, I'm going to use Desmos to work these problems or look these over, and so you'll be able to see the formulas right here. But again, just don't focus on those. The questions that I'm talking about are giving examples of, they just give you the graph, so you just have to go by what you see in the graph here. Okay, it's just easier to demonstrate this on Desmos. So the definition of a one-to-one function: a function f of x is one-to-one if whenever f of a equals f of b, then a equals b. So in other words, what this is saying is that if there are two numbers that when I plug them into the function, evaluate the function at those two numbers, and I get the same y value, then it turns out that they have to be the same number. Okay, and so what you'll have if you have a function that's one-to-one is that for every y value that's possible output, there's only one way to get that, only one number to plug in to get that output. And so graphically, if you're just going by the graph, right, there's something called the horizontal line test. And if you didn't watch the video about the vertical line test, it works very similar to that, but you might want to go back and watch the vertical line test video first. So in order to be a one-to-one function, right, it has to be a function first. So you have to be able to tell whether the graph of a function represents y as a function of x. And again, that's what we're talking about here. We're talking about a one-to-one function that represents y as a function of x. Okay, so that's what the horizontal line test. And the horizontal line test says that if every horizontal line cuts through the graph or intersects the graph in at most one point, that means the function is a one-to-one function. Otherwise, it's not. Okay. So let's take a look at this first graph here, the graph here in red, and what we're going to think about are horizontal lines and how they intersect this graph. We're going to look at all possible ways that can happen and just see what happens. So again, on Desmos, I can just draw the horizontal line here and move it back and forth. All right, so I'm going to start down here at the bottom. If I draw a horizontal line right here, I can see that it intersects the graph in at most one spot, this spot right here. And so that's fine according to the horizontal line test so far. But I can see that as I move this up, right, then some other things are going to happen here. And in fact, right, if I move this horizontal line up at 0, I'll get 3 different intersection points. And so that says that this graph, the graph of this function, right, it's not a one-to-one function. Okay, there are 3 different x numbers that I could plug in: -2, 0, and 1. And if I plug any of those 2 in, I will get 0 as the y value. So there's 3 different ways to get a y value of 0. So therefore, this is not a one-to-one function. Okay, and you can see that just about any vertical line in this region here will intersect the graph in 3 spots. And then once we get above there, that's okay. But this ruins it. The fact that some horizontal line cuts through here 3 times, that means that this is not a one-to-one function. All right, the next example, we're going to look at this orange function here. And if I start down here at the bottom looking at horizontal lines, I can see that the horizontal lines down here do not intersect the graph at all. And that's okay according to the horizontal line test, right? We're talking about at most one intersection point is what we're looking for. So as we start moving this horizontal line upwards, there's no intersection points, and then once we get to 2 right there, we will start getting 1 intersection point right there. Okay, and then if we keep going up, that's okay. Any place through here, 1 intersection point. And so anywhere we put this horizontal line that we can see, right down here, we get 0 intersection points. Up here, no matter kind of where we put it up here that we can see, we get 1 intersection point. So that says that this orange graph is the graph of a one-to-one function. It's the graph of a function, right, according to the vertical line test. And now the horizontal line test says that this is also one-to-one. So this is the graph of a one-to-one function, right? Every horizontal line cuts the graph in either 0 or 1 spot. All right, on the next example, right, if you take a look at this, there's down here, the horizontal lines don't cut the graph at all. But once we start getting in between -2 and 2, you can see that there are quite a few intersections, right? Any horizontal line between -2 and 2 is going to cut the graph in a bunch of spots, right? So now it's not just 0 or 1. Here I can actually see 1, 2, 3, 4, 5, 6 intersection spots. And in fact, if you go by the graph here, there's actually infinitely many, but you don't really need to worry about that in these problems. The fact that this horizontal line cuts through the graph in more than one spot and more than one point, right, means that this is not a one-to-one function at all. Okay. So this is not the graph of a one-to-one function. All right, the last example is this green one. All right, and you can see on the green one, all right, I move this up and down. And these horizontal lines cut through the graph in one spot, right? Each one of those. Same things here, here, here. And then these don't look like it cuts through at all. And again, we just kind of have to go by what we see on these problems. They do actually cut through. It's just way far off to the right. But again, don't worry about that. Just go by the picture that you've got. And so it looks like here, right, that this is the graph of a one-to-one function. Every horizontal line cuts through the graph in either 1 or up here it kind of looks like 0, right, spots, and that's fine, right? Every horizontal line cuts through the graph in at most 1 point, or intersects the graph of the function in at most 1 point. So this is the graph of a one-to-one function. And that's it.